Welcome to our deep dive today. As experts in machine learning, data science, and mathematics, you'll find this paper, DeepSeek-Coder. When the large language model meets programming, particularly relevant, it's all about code intelligence and how open source models are starting to, well, really give those giants like Codex and GPT a run for their money.
Yeah, it's really impressive stuff.
This paper introduces DeepSeek-Coder.
A series of models ranging from, 1.3B to 33B parameters.
Wow.
And get this, trained on a massive 2 trillion token data set.
2 trillion, that's wild.
87 programming languages. The scale is just, well, mind-blowing.
So what kind of results are we talking here? What did they find?
The results are, well, pretty amazing. DeepSeek-Coder-based 33B, it outperforms all the existing open source code models. And then there's DeepSeek-Coder Instruct 33B. That one surpasses GPT 3.5 Turbo on most code-related benchmarks. Oh, and you've got to hear this. DeepSeek-Coder-based 7B, it's showing competitive performance against models 5 times its size.
5 times, so it's like punching way above its weight class.
Exactly.
That's incredible.
Really efficient, too.
Yeah, it's pretty clear the authors were meticulous in their approach, right from the start with the data collection.
Yeah, they were very thorough. A lot of effort went into making sure they had a really high-quality data set that reflects real-world coding. They really dug deep.
So where did they get all this data from?
Well, they had a variety of sources.
Like what?
Like 87% was straight-up source code.
Okay, so mostly code.
Then 10% English code-related text and 3% Chinese text. And they got this stuff from all sorts of places, like GitHub, Stack Overflow, you name it.
So they didn't just scrape everything they could find.
Right.
They were selective.
Yeah, exactly.
So how did they decide what was good code and what was, well, not so good? What was their filtering process?
It was multi-stage.
Multi-stage, so like layers of filtering.
Yeah, they started with a rule-based filter to weed out those files with things like super long lines.
Okay.
Or like a low percentage of alphabetic characters, stuff that's often like machine-generated or poorly structured code.
Right.
But they didn't stop there. They went beyond individual files. They wanted to understand how things worked within whole repositories.
So they're looking at the bigger picture, not just isolated bits of code.
Exactly. And they use dependency parsing for this to, organize files in a sequence that reflects how developers actually structure their projects.
Oh, that's smart. So they're teaching the model to understand code, not just in isolation, but also like in the context of a real project.
Precisely. It's all about real-world applicability. To make sure the data was top-notch, they did repository-level deduplication to, get rid of any redundancies. And finally, they used a combination of compilers, quality models, and heuristics to get rid of any remaining low-quality code.
Wow, it sounds like they really covered all their bases to build this clean, comprehensive data set. Okay, so we've got the data sorted. Let's talk training.
Okay, so they used 2 main training objectives. Next token prediction, which is, pretty standard, and then this really cool approach called fill in the middle, or FEM.
Okay, so next token prediction is basically the model is trying to guess what comes next in a sequence. But what's this FAM all about?
So FEM, it's all about training the model to complete code snippets by filling in missing parts. So it's like forcing it to understand code structure and those dependencies, even when parts of the code are missing.
I can see how that would be incredibly helpful for real-world coding situations.
Yeah.
Where you're working with those incomplete snippets or trying to figure out how to piece things together. But did focusing on FEM have any drawbacks?
Well, their studies on FEM showed that while it made the model better at filling in missing code, there was a bit of a trade-off. Its overall code completion ability, like finishing an entire function, it dipped a bit.
So it got really good at one specific thing.
Yeah, but maybe at the expense of the bigger picture.
So how did they strike a balance?
They chose a configuration called the 50% PSM rate for DeepSeek-Coder.
Okay, so it's all about balance. What about the nitty-gritty of training? Like, what tokenizer and model architectures did they use?
Okay, so they trained a tokenizer with a vocab size of 32,000 tokens. And for the model architecture, they had a few different sizes: 1.3B, 6.7B, and 33B. This way, there's something for everyone depending on what you need it for. And these models, they were all built on the same framework as the DeepSeek large language model, which uses a decoder-only transformer architecture. And they threw in some fancy tricks like rotary position embedding, grouped query attention, flash attention v2 to make it all run smoothly and, perform well.
I bet training these models required a ton of computing power.
Oh, absolutely. They used the HAI LLM framework to make things more efficient. But even then, they needed clusters of those NVIDIA A100 and H800 GPUs.
Wow, that's some serious hardware.
And for the optimizer, Adam W. with a 3-stage learning rate scheduling policy. They scaled the batch sizes and learning rates based on those scaling laws from the DeepSeek LM paper.
So they're constantly adjusting the learning rate throughout training to get the best performance, right? Now, I remember reading about how they wanted to make sure the model could handle those really complex coding tasks.
The ones with a lot of code.
Yeah, so they extended DeepSeek-Coder's context window, didn't
Oh, yeah, big time. They took it all the way to 16,000 tokens.
16,000.
Yeah, and they did it by, well, reconfiguring those RoPP parameters using a linear scaling strategy. It's pretty clever. This way, the model can keep track of relationships between tokens, even across, huge chunks of code.
That's crucial for handling those bigger, more intricate coding challenges, right?
Absolutely, especially at the repository level.
But a big context window alone isn't enough. They also had to train the model to actually understand instructions and respond appropriately. How do they do that?
So they created DeepSeek-Coder Instruct, which is basically the instruction-tuned version of the model. They fine-tuned it on this data set of really well-crafted human-written instructions, and they use the alpaca instruction format for that. And the instructions, they're designed to be clear and, well, impartial. And every turn in the dialogue is marked with this EOT delimiter token, so the model really understands the flow of the conversation.
So they've given the model a solid understanding of how humans actually communicate when it comes to coding, right?
That's the idea.
What were the training parameters for this instruction tuning?
Let's see, a cosine learning rate schedule, a massive batch size of 4 million tokens, and a total of 2 billion tokens for the whole shebang.
So they really went all in on this instruction tuning, making sure the model can understand and respond to those complex human instructions in a coding context.
Exactly. That's the goal. Welcome back to our deep dive into DeepSeek-Coder.
We've talked about how they built this model, the data, the training.
Now it's time to see how it actually performs.
Yeah, let's get to the benchmark results.
They tested DeepSeek-Coder on a whole bunch of benchmarks.
A whole bunch.
Yeah, covering code generation, code completion, cross-file interactions, even mathematical reasoning.
Okay, so starting with code generation.
Right, they used human, evil, and MBPP. Those are kind of the standard benchmarks.
Yeah, as a data scientist, I'm definitely familiar with those. Human evil is all about, seeing if the model can generate code that actually solves a task based on a natural language description.
MBPP is similar, but the problem descriptions are more complex.
Right. More challenging.
Exactly.
So how did DeepSeek-Coder do?
Well, DeepSeek-Coder based on 3B got state-of-the-art results on these benchmarks.
It's competitive.
It's more than competitive. It actually beat out Code-Llama-based 34B.
So it's outperforming some of the bigger models.
Yeah, which is pretty impressive.
That's amazing. Now, what about the instruction-tuned version? DeepSeek-Coder Instruct, right?
Yeah, so DeepSeek-Coder Instruct 33B, it actually did better than GPT 3.5 Turbo on Human Evil.
Wow, so their instruction tuning really paid off.
They also tested on DS1000.
DS1000, that's the one focused on real-world data science workflows, right?
Yeah.
With Matplotlib, NumPy, Pandas, all those libraries.
Yeah, exactly.
It's a good one for seeing if a model can handle those real-world complexities.
And it did well. High accuracy across all those libraries.
So it's not just good at those theoretical problems.
Yeah.
It can actually handle the messy stuff you find in real projects.
Right. And then to really push things, they created this LeetCode contest benchmark.
LeetCode, those problems can be brutal. Lots of algorithms, data structures, really challenging stuff.
And they made sure the LeetCode problems were out of distribution, meaning they weren't part of the training data.
So it's a real test.
Yeah, and DeepSeek-Coder Instruct, especially the 6.7B and 33B models, did really well.
Even better than GPT 3.5 Turbo on some of those problems.
It was pretty remarkable considering how hard those LeetCode problems are.
Did they do anything special to help it with those LeetCode problems?
Yeah, they found that using chain of thought prompting really helped, especially on the tougher problems.
Chain of thought, so they're prompting the model to think step by step, kind of like how a human programmer would approach it.
Yeah, and it seemed to make a big difference.
Interesting. So it's not just about brute force. They're actually trying to guide the model's thinking.
Make it more strategic.
Now let's talk about DeepSeek-Coder's fill-in-the-middle abilities.
FM. Yeah, that's a big one for those real-world coding tools.
Absolutely. You're constantly trying to fill in those missing parts of code.
And DeepSeek-Coder did great here.
So it's good at filling in the blanks.
Yeah, they had this dedicated FEM benchmark, and it consistently outperformed other open source models.
How did the different sizes compare?
Even the smallest one, the 1.3 billion parameter model, It did better than bigger models like StarCoder and Codalama.
Okay, so size isn't everything.
It's about the training data and that FEM approach.
And as the models got bigger, the performance just kept getting better, right? So there's still something to be said for model capacity.
They also looked at how well it handles those multi-file coding scenarios using the cross-code evil benchmark.
Cross-code evil, that's where it has to understand the connections between multiple files.
It's essential for real projects. And it did well, consistently outperforming those other open source models.
So that repository level pre-training really made a difference.
It seems like it.
They're not just teaching it to write code, they're teaching it to understand how code fits together in a real project.
Yeah, they really tried to simulate the complexities of real-world development.
Now, they also tested DeepSeek-Coder's math problem-solving skills, right?
Right, they used the program-aided language reasoning method.
PL, so they're basically asking the model to write a program that solves a math problem.
Exactly. It's interesting to see them test a code model on something that's usually done with, like, symbolic AI or specialized math software.
Yeah, how did it do?
DeepSeek-Coder, especially the 33B version, did really well across all the benchmarks they used.
So it's not just writing syntactically correct code.
It's actually understanding the math concepts.
And then translating that into working code. That's pretty impressive.
It suggests a deeper level of reasoning and problem solving.
Yeah, it seems like it could have applications beyond just writing code.
Definitely. Okay, so we've covered a lot of ground here. DeepSeek-Coder's performance on all these benchmarks.
Yeah, it's shown it can handle code generation, code completion, multi-file dependencies, even math problems.
Pretty impressive, right? And they didn't stop there.
There's more.
There's DeepSeek-Coder v1.5. They pre-trained it on this massive multimodal data set.
Multimodal, so it's not just code anymore.
Right.
Let's dive into that when we come back for the last part of our deep dive. Welcome back to the final part of our deep dive into DeepSeek-Coder.
We've seen how well it does on all those coding tasks and those math reasoning tasks.
Right. It's really impressive.
Now let's talk about DeepSeek-Coder v1.5. They continued pre-training, but this time from a more general large language model.
So they're moving beyond a purely code-focused approach.
Exactly.
More towards this multimodal training.
Right. For DeepSeek-Coder v1.5, they use this massive 2 trillion token data set. But it's not just code anymore. It's got code, natural language, and math data all mixed in.
They're really expanding the knowledge base here.
Yeah, and the idea is by grounding the model in this wider range of information, they could improve its natural language understanding and reasoning abilities.
So it's not just about generating code. It's about understanding what the code is doing, what it means.
Right, and being able to follow more complex instructions.
So what happened? Did this multimodal pre-training work?
Well, it's interesting. DeepSeek-Coder v1.5, it actually did a little bit worse on some of the coding benchmarks.
Really?
But it significantly outperformed the original DeepSeek-Coder on those tasks involving math reasoning and natural language understanding.
So there's a trade-off.
It seems like it.
A little less specialized in coding, but much better at the general stuff.
Yeah, it's a balance, right? Focusing too much on one area might limit its abilities in other areas.
It's fascinating to see how these models are evolving and how the research is pushing the boundaries of what's possible.
It really is. DeepSeek-Coder is a great example of how open source models are catching up to those closed source giants.
And the researchers have been so open with their process, sharing all the details about how they collected the data, trained the models, everything.
Yeah, it's great to see that level of transparency.
It really opens up possibilities for other researchers and for the whole field of code intelligence.
With DeepSeek-Coder being open source, more people can access these advanced tools, and that could lead to some really amazing innovations.
Absolutely. Well, I think we've covered a lot of ground here today.
Yeah, we've gone deep on DeepSeek-Coder.
If you want to learn more, be sure to check out the paper. We'll have the link in the show notes.
Thanks for joining us.